Okay, before we do these problems, let's check out this graph. It's a quadratic function, right? Makes a parabola. So let's say maybe this is the graph of total profit at a company. It starts slowing down. It reaches lowest point, almost goes into the negatives where they're losing money, and then all of a sudden they start making a profit again. So maybe the company's interested, like how fast are we growing right here, right? We're talking about how fast we're growing at this instant. We're not talking about how fast we're growing by using two different points. That's finding the slope between 2 points. That's the average rate of change. I'm not talking about the slope between 2 points. I'm talking about the slope at exactly 1 point. How do we find out what that slope is of this line right here that I just drew? We call this line a tangent line because it touches the graph only at one spot, at this dot I've highlighted. And the slope of the tangent line is something we investigate in calculus. Before in math, we did it to death. Find the slope between 2 points. That gives us an idea of how fast we're changing. But we want an instantaneous slope. We want to know exactly what the slope is at just 1 point, right here, not between two different points. And so to do that, we start with limit notation. Okay? And so here's how you find the slope using slope at a point using limit notation. The limit as h approaches 0. There's two ways. I'll show you the other way. And it's the function of f of x plus, actually this is in general, we should do f of a plus h first minus f of a all over h, where a is the point you're trying to find the slope on. Like in this graph, here's my curve again. Let's say I want to know what's the slope right here, where it touches at x equals 1. Okay, a would be 1 in this graph. So like in this first problem, I'm using 1. I'm going to plug in 1 in for a. And you might be saying, okay, well, what the heck is the h? H is a number that's approaching 0. And the whole point of plugging in h is because, look, this is just the slope formula. This is y2 minus y1. And then on bottom, it's supposed to be x2 minus x1. But we're finding the slope between 2 points that are infinitely close to one another. In other words, they're virtually the same point. Okay? So that's why h is 0, because the difference between the 2 points in our slope formula, y2 minus y1 over x2 minus x1, the 2 points we're picking are infinitely close to another. That's why I'm taking the limit as h approaches 0. And then the y values that are coming out, those will converge to some value. So this is the formula for finding the slope between 2 points. But there's another way. You could do it like this. The limit as x approaches a for f of x minus f of a all over x minus a. These both do the same thing, just with different notation. Because look, x is getting infinitely close to whatever value you're trying to find the slope at. So in this case, x equals 1. In this case, we'd plug in 0 in for a. Okay? Because f of x is like a y value, right? And f of a is a number that's infinitely close to x. So you're you're calculating two y values that are infinitely close to each other on the x-axis. This is also approaching 0, right? If you were to just plug in a in here, a minus a would make 0, just like this one is, okay? So the idea of finding a slope in calculus is to find the slope between 2 points that are infinitely close to one another. Okay, so now on to this problem. They want the slope, the tangent line, and the normal line to the curve. So let's start with the slope. We need a slope at 1 point. So that means we're going to plug in 1 in for a into this formula. And just a note, you could do this with the other formula I just gave you, okay? You'd be plugging in 1 in for a as well. Okay, so limit as h approaches 0 of f of 1 plus h minus f of 1. Notice I'm just replacing a with 1. That's the only thing I've done so far. Formula looks a little ugly, but I've done what it said to do. I plugged in that location where I'm supposed to find the instantaneous slope. Okay, now we can use that function notation. F of 1 plus h, that says plug 1 plus h everywhere where you see an x up here. So we can do that. Still calculating a limit as h approaches 0. And then 1 plus h goes in for x. That gets squared minus 4 times 1 plus h. All I've written so far is this part of the formula. Okay? Oh, sorry. It's better yet, this one. That is the part I've done, but A is 1 in our example. So all I've done so far is what I've circled. That's right here. I still need to subtract it by f of 1. And f of 1, that notation just says, tell us what the value is when you plug in 1 into the function. So if I plug in 1 into this function, 1 squared is 1. 1 minus 4 times 1 is 4, so 1 minus 4 is negative 3. This is all still being divided by h. You might be thinking, well, I can't figure out this limit because it's a divide by 0 error, but every time you do this, an h should cancel out, okay? So that's the limit as h approaches 0. I'm going to expand this. It's 1 plus h times 1 plus h off to the side, right? So that should be 1 plus 2h plus h squared. And then this is minus 4 minus 4h. And then minus a negative 3, that's going to be plus 3. Still have a divide by 0 problem, so let's keep simplifying. 1 minus 4 is negative 3. Negative 3 plus 3 is 0, so these numbers eat each other up, and that's supposed to happen. Okay, so in the numerator, I'll put it in descending powers. I've got h squared, and then plus 2h minus 4h, that makes minus 2h here. It's all being divided by h. Still the limit as h approaches 0. I can factor out an h from the numerator. And look, the h's cancel out. So that cancels out. So now that I've canceled those out, I've just got the limit as h approaches 0 of h minus 2. You can just plug in 0 into this expression here. 0 minus 2 is negative 2. We've got it. After all that work, we just found out the slope at x equals 1 is negative 2. So that's our first part. We just found the slope. The slope at x equals 1 is negative 2. That's that instantaneous slope that I was drawing for you. We need to find the equation of the tangent line. So that's y equals mx plus b. So this is part A, we could say. Part B, we need to find a y equals mx plus b of that tangent line that I graphed for you. And let's do this last part of the instruction. Draw a graph of the curve, tangent line, normal line. So x squared minus 4, if you're not sure what that is, let's go to Desmos. X squared minus 4x. Graph looks like this. I got it typed in, okay. And then we're asked for the instantaneous slope at x equals 1. So x equals 1 is right here on the graph, right? So the slope we just found is negative 2. So that means if we were to graph a tangent line, needs to touch only at this point at 1 comma negative 3. Okay, and so the line should perfectly touch at this point, and it should have a slope of negative 2. Okay, so to make that happen, we're going to plug in negative 2 in for m. And then we need to find out the y-intercept. And by the way, we're plugging in negative 2 because that's the whole point of all that notation that we just did. We found out the instantaneous slope. Okay, so we just need a point to plug in. So we've got x equals 1. What's the corresponding y value? To figure that out, we just got to plug 1 into this equation down here. 1 squared is 1. 1 minus 4 is negative 3. So we have a y value of negative 3 when x equals 1. So you can plug in negative 3 in for y. You can plug in 1 in for x. And then simplify and solve for b. So negative 2 times 1 is negative 2. If I add 2 to both sides, I get negative 1 equals b. That's the y-intercept. So the full equation of our tangent line is y equals negative 2x minus 1. And there we go. We got the second question they asked for, the tangent line. To find a normal line just means it's perpendicular. Actually, before we do that, let's graph what I just did here. We had y equals negative 2x, I forgot what it was, minus 1. Look, it's touching at 1 comma negative 3, at the x coordinate of 1. It only touches once. So we have successfully created the equation of a tangent line when I graph this in Desmos. Okay, so part C, though, they want a normal line, which just means they want something that's going to be perpendicular. So I'm going to make a guess so you can see it. I don't know what it is yet. Oh, I'll probably just have to do the math. What is it? 4, 5, or 2? Oh, there we go. I got it, I think. Oh, it's close. Not quite. There we go. No, that's not it either. Okay, let's try 7/2. That's it. Okay, so the green line is the equation of the normal line at that point. In other words, it's the equation of a line that's perpendicular. That's all normal means. Okay? Normal means it's perpendicular to a surface or to a curve. And so I have graphed the normal line for you, but I'll show you how to find it. It's just like finding perpendicular slopes like you've done previously in math. Look, the equation of our tangent line is negative 2x minus 1. If we want to be perpendicular at this point, then we want the reciprocal. So this is how we're going to find the normal line. Okay, so you got to plug in a point for x and for y. So I'm going to plug in 1 in for x and negative 3 for y. And then I've got to solve that equation for b. So I've just got to subtract 1/2 from both sides. So it's negative 3 over 1. That's negative 6 over 2 on this side, right? Negative 6 over 2. Subtract 1/2, so that's negative 7 over 2. Okay? That's the y-intercept we need. So the equation of the normal line is y equals 1/2 x, right? Perpendicular slope, negative reciprocal, subtracted by 7/2. And in Desmos, I've graphed that for you. Okay? You can use a graphing calculator to help you on these questions. That's not such a big deal. The book just wants you to be knowing visually what these things are, what the tangent line, what the normal line are. So that's just what I've been doing in Desmos. Okay. I think we got everything. That's it for that question. Okay. Let me do. Oh no, I lost it. I'll do this one over here, but I need more room. So hold on. I already have a video for this type, but I will do this one. Again, that way you can have more to use. Okay, they want the slope at x equals 0. Not the slope between 2 points, the slope at 1 point, which means we need this notation. We want to find the limit as, like I just showed you on the other screen, the limit as h approaches 0 of f of 0 plus h, remember because it's a plus h in the original formula, minus f of 0 divided by h. Okay, the slope between 2 points that are infinitely close to one another. So if we follow the notation, this says we're supposed to plug in 0 plus h into the function. So 0 plus h needs to go down here. Oh, this is actually going to be too easy. Let me change this to x equals 1. Sorry. And I'm doing that because I know in the book it has a different number. I don't want to cut corners here. So we're doing 1. The limit as x approaches 1. Okay? So if I plug in 1 plus h into this function, then I've got 1 over 1 plus h in for x plus 1. This notation says plug 1 plus h in for x. So this is what it looks like if you do that. And then this notation says what happens when you plug in 1 into the function. Well, if I plug in 1, 1 plus 1 is 2, so this is 1/2 for f of 1 over h. Divide by 0 problem, and we got scary fraction problem too, so we got to simplify a bit. The limit as h approaches 0, this is 1 over 2 plus h minus 1 over 2 all over h. Okay, so we need common denominators in order to do anything with these fractions. So I'm going to multiply each fraction by the opposite's denominator. So I'm going to multiply the top and the bottom of this one by 2. And then I'm going to multiply the top and the bottom of this one by 2 plus h. Oh, that's supposed to be minus. Now they have common denominators. And this is the yucky part. It's still all being divided by h, right? This is the limit of all this stuff. Okay, so but now they have common denominators. Now we can subtract the tops. Just watch out when you do this. You're subtracting the entire second numerator, right? So you're distributing that minus sign. That's minus 2 minus h. So 2 minus 2 makes 0, but this is a negative h left over on top, not a positive h. Okay, and so if you're wondering how to rectify this, look, isn't this the same thing, what I'm about to do? Right? This is a division symbol, so I rewrote it like this, and I can make it into a fraction, and now we know how to divide two fractions, right? We flip and multiply the second fraction. So this is the limit as h approaches 0 of negative h over 2 plus h times 1 over h. So these h's can cross cancel. Now we don't have a divide by 0 problem. Now we made those h's cross cancel. Now we can just plug in 0 to find out the limit. 2 plus 0 is 2. 2 times 2 is 4. So we've got negative 1 over 4. That's the instantaneous slope, negative 1/4. So all that work, we just found out the first question. The instantaneous slope is negative 1/4. Okay, for B, we're supposed to find the tangent line, so that has the same slope. That's the instantaneous slope. We just need a y intercept. So to find that, we need to know what the y value is when x equals 1. So if you plug in 1 into that function, 1 plus 1 is 2. So 1 over 2 is our y value. So to find out that b, we've got to plug in 1/2 in for y, 1 in for x. Okay, and then to get b by itself, I got to add 1/4 to both sides. So this is like 2/4 plus 1/4, that makes 3/4, right? So that's our y-intercept, 3/4. That part's just algebra. The calculus part's done, right? Because C is asking for, the second part is asking for the normal line to the curve. So we need a negative reciprocal of that slope. Negative 1/4 x, the negative is positive. And a negative reciprocal means change negative to a positive, and then you got to flip it. So that should be a 4x plus some b. So to find out what that b is, we'll plug in that point again. It needs to cross at 1, 1/2. And then if you subtract 4 from both sides, you're subtracting the 8 over 2 from both sides, right? So that's negative 7 over 2 for b. Okay, so the equation of the normal line is 4x minus 7 over 2. Okay, and then for the graphing part, go ahead and use Desmos. The original function, I think, was, what did I do? 1 over 1 plus x, or x plus 1 in other words. And so the equation of our normal line was, the normal line was 4x minus 7/2. Y equals 4x minus 7/2. So at our point, what was it? X equals 1, I said? Look, it's perpendicular. Doesn't that look like it's crossing at a right angle? And we could verify that by graphing our tangent line, negative 1/4 x plus 3/4. Y equals negative 1/4 x plus 3/4. There we go. The tangent line is crossing at just one point on the graph, at x equals 1 like we wanted. And the normal line is perpendicular. So that's what they want you to be doing when they say graph it, just to see those graphs in action.